Welcome to the video on rational functions. So we've touched a little bit on rational functions with our reciprocal function 1 over x. That's one form of our rational function. In this video, we'll be focusing on equations such as this, where we have a linear in the numerator and a quadratic in the denominator, or a quadratic in the numerator and a linear in the denominator. So to find your vertical asymptote, you'll set your denominator equal to 0 and solve for x. So your vertical asymptote will be x equals whatever that value is. For your x-intercept, you'll set your numerator equal to 0 and solve for x. You'll write your x-intercept as a coordinate of that value, comma 0. For your y-intercept, it'll be 0, comma, your constant in your numerator divided by your constant in your denominator. Because if you plug in 0 for x, what you'll be left with in this first one is b over e, and the second one would be c over e. For your horizontal asymptote, it'll be in the form of y equals. So if the degree of your numerator is less than the degree of your denominator, you'll have a horizontal asymptote at y equals 0. So if you had a linear function in your numerator and a quadratic in your denominator, your degree, the value in the exponent, would be higher in your denominator, so you would have a horizontal asymptote at y equals 0. If your degree of your numerator is equal to the degree of your denominator, for example, if you had 3x squared plus 2x over 2x squared minus 3x plus 1, since the highest degree is equal to each other, your horizontal asymptote will be at y equals the coefficient of your highest degree variable in the numerator over your coefficient of the highest degree variable in the denominator. So this would be 3/2. Finally, if the degree of your numerator is greater than the degree of your denominator, if you had a quadratic over a linear, then there will not be a horizontal asymptote, but it will have an oblique asymptote. So your oblique asymptote is in the form y equals mx plus b. So if the degree of the denominator plus 1 is equal to the degree of the numerator, the equation will have an oblique asymptote that can be found by taking the first two terms from dividing the numerator by the denominator and substituting them in for m and b. So we have three quick examples. Here, your degree of your numerator is less than the degree of the denominator, so your horizontal asymptote will be y equals 0. For the second one, we have the same degree, so it would be your coefficient of the numerator over the coefficient of the denominator. So it would be y equals 1/3. And in this third one, your degree of your numerator is 2, so it's greater than the degree of the denominator. So there's no horizontal asymptote. But we can find our oblique asymptote by taking 3x squared minus 2x plus 4 divided by x minus 3. So we'll use synthetic division. We have our 3, -2, and 4. Our 0 of the denominator is positive 3, so we'll put a 3 here. Bring down this 3. 3 times 3 is 9. -2 plus 9 is 7. 7 times 3 is 21. 21 plus 4 is 25. So to find the equation of our oblique asymptote, we'll just take our first two values. The first one's going to become our slope, m, and the second one will become our y-intercept, b. So our equation for our oblique asymptote would be y equals 3x plus 7. So that's how you would find horizontal and oblique asymptotes. So here we have our first IB practice question, and we are allowed to use the calculator for this. It says find the x-intercept, y-intercept, vertical asymptote, and oblique asymptote for the function f of x equals x squared plus 3x minus 2 over x plus 2, where x is not equal to -2. Then sketch the graph for -10 is less than or equal to x is less than or equal to 10. So we'll start with our x-intercept. So our x-intercept is when y equals 0. So we'd have 0 equals x squared plus 3x minus 2 over x plus 2. When we multiply by x plus 2, we still get 0 equals, and then it'll be x squared plus 3x minus 2. We can't factor this, but we can use the quadratic formula. So x equals -b, so -3 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this equals negative 3 plus or minus the square root of 9 plus 8 over 2, which is negative 3 plus or minus the square root of 17 over 2. We can put this in our calculator and get that our x-intercepts are approximately negative 3.562 and positive 0.562. So as coordinates, those would be negative 3.562, comma 0 and 0.562, comma 0. Now we can find our y-intercept. So our y-intercept is just going to be negative 2 over 2 because we'd plug in 0 for x. So negative 2 over 2 equals negative 1. So the y-intercept will be 0, comma, negative 1. So we have 1 point here, 2 more points here. Our vertical asymptote will be when the denominator is equal to 0. So 0 has to equal x plus 2. We'll subtract 2 from both sides. So our vertical asymptote is x equals negative 2. And then, since the degree of our numerator is greater than the degree of our denominator, we'll have an oblique asymptote, which we can find using synthetic division. So the 0 of our denominator is when x is negative 2. And then we'll put our coefficients in here, 1, 3, and negative 2. We'll bring down our 1. 1 times negative 2 is negative 2. 3 minus 2 is 1. 1 times negative 2 is negative 2. Negative 2 minus negative 2 is negative 4. We only really need these first two values. So it will be y equals 1x, so just x plus 1. So that is our oblique asymptote. Then we'll go ahead and sketch the function from negative 10 to 10. So negative 10, 9, 8, 7, 6, negative 5, 4, 3, 2, 1, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a point at negative 3.562, comma 0. So that'll go here. And then at 0.562, comma 0. At 0, negative 1. We have a vertical asymptote at x equals negative 2. And an oblique asymptote at x plus 1. So at 1, we'll put a point. And we'll draw our asymptote through there. So here is what our function would look like. It'll get closer and closer to these asymptotes, but never actually touch them. So these would be our answers to this problem. Our x-intercepts, our y-intercept, our vertical asymptote, our oblique asymptote, and then our sketch of the graph. Now we have our second IB practice question, which is no calculator. It says the function f of x equals 2 plus 3x over x minus 2 for x is not equal to 2. Sketch the graph with its x-intercepts, y-intercepts, and asymptotes. So we're going to start by rewriting this function. So we have f of x, and we want a common denominator. So we're going to multiply this 2 by x minus 2 over x minus 2. So it'll be 2x minus 2 over x minus 2 plus 3x over x minus 2. So this will equal 2x plus 3x, which is 5x, and then minus 2 times 2, so 4, all over x minus 2. So our x-intercept is when 5x minus 4 equals 0. We'd add 4 to each side. So we get 5x equals 4. And then we'll divide both sides by 5 to get x equals 4 over 5. So we have a point at 4/5, comma 0. The y-intercept would be negative 4 over negative 2, which is positive 2. So it would be 0, comma 2. Our vertical asymptote is when the denominator equals 0, so x minus 2 equals 0. We'd add 2 to both sides to get that x equals 2. And then because the degree of the numerator is equal to the degree of the denominator, our horizontal asymptote will equal the coefficient of our highest degree in the numerator over our coefficient of the highest degree in the denominator. So it'll be y equals 5 over 1. So our horizontal asymptote is y equals 5. So to sketch this graph, we'll start by drawing our asymptotes. So we have x equals 2. We have y equals 5. We have a point at 4/5, 0. And we have a point at 0, 2. So our function will be like this. And then it'll also be in the opposite corner. So there's our sketch of f of x. It says to find f inverse of x. So we'll swap our x and y. We'll say x equals 5y minus 4 over y minus 2. We'll multiply both sides by y minus 2. So we get x times y minus 2 equals 5y minus 4. We'll distribute our x. So we get xy minus 2x equals 5y minus 4. We'll get our y's on the same side as each other. So we'll subtract 5y from the right and the left. And then we'll add 2x to both sides. So we get xy minus 5y equals 2x minus 4. We'll factor a y out from the left, so y times x minus 5 equals 2x minus 4, and then we'll divide both sides by x minus 5. So we'll get that f inverse of x equals 2x minus 4 over x minus 5. And then we want to know for what values of x does f of x equal f inverse of x. So we'll set the two functions equal to each other. So 5x minus 4 over x minus 2 equals 2x minus 4 over x minus 5. We'll go ahead and cross multiply. So x minus 2 times 2x minus 4 equals 5x minus 4 times x minus 5. So for the left side, we'll get 2x squared minus 4x minus 4x plus 8 equals, and then we'll get 5x squared minus 25x minus 4x plus 20. So we'll combine all of our like terms on the left side of our equation. So we'll subtract 5x squared from both sides to get negative 3x squared. On the right side, we have negative 29x, so we'll add 29x to both sides. So that'll give us 21x, and then we'll subtract 20 from both sides. So minus 12 equals 0. We'll factor out a negative 3, so we'll get negative 3 times x squared minus 7x plus 4 equals 0. We can't factor it, so we'll use our quadratic formula. So it'll be x equals negative b, so negative negative 7, so positive 7, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this equals 7 plus or minus the square root of 49 minus 16 over 2. 49 minus 16 is 33, so x equals 7 plus or minus the square root of 33 over 2. So that's when f of x would equal f inverse of x. So in summary, Our rational function is when f of x equals ax plus b over cx squared plus dx plus e, and when f of x equals ax squared plus bx plus c over dx plus e. To find our vertical asymptote, you set the denominator equal to 0 and solve for x. To find your x-intercepts, you set your numerator equal to 0 and solve for x. For your y-intercept, it'll be 0, comma, the constant in your numerator divided by the constant in your denominator. For the horizontal asymptote, if the degree of your numerator is less than the degree of your denominator, it'll be y equals 0. If the degree of your numerator is equal to the degree of your denominator, it'll be y equals the coefficient of your highest degree variable in the numerator over the coefficient of your highest degree variable in your denominator. And if your degree of your numerator is greater than the degree of your denominator, there will be no horizontal asymptote, but it'll have an oblique asymptote. So to find your oblique asymptote, if the degree of your denominator plus 1 is equal to the degree of your numerator, the equation of the oblique asymptote is found by taking the first two terms from dividing the numerator by the denominator and substituting them in for m and b in your equation y equals mx plus b. That's all for this video. Thank you for watching.